I kind of mentioned this last time. We're talking about the domain and range for our sine and cosine functions. Now, of course, as far as the domain goes, you can see it's going to be the set of all real numbers. So basically, you have no restriction on what value you can put inside your sine function. Now, as far as the range goes, let's actually take a look. Okay, so if you think about the unit circle, then of course we know that's a circle centered at 0, 0 with the radius of 1. So we know at most, if you look at your sine and cosine values, they are going to go from +1 to -1, right? And +1 to -1 on the y-axis. So your y values are actually going to stay between -1 and +1. Same thing for those x values. And remember, we assign cosine as the x values if you think about this in terms of ordered pairs, and sine as our y values. So basically the range for each of those functions is going to stay within those 1 and -1 values. I'm not sure why this is not letting me scroll anymore. Now, the other thing I want to talk about is, of course, and we kind of discussed this in section 1. Now, if you add, or for that matter, even subtract 2 pi from a given value of t, where is it going to bring you back at? Yes. At the same point, right? So if I start by adding 2 pi to 0, it's basically going to make 1 full revolution and bring me back. Same thing here with pi halves. If I add 2 pi to it, I'm basically making a complete revolution, which also obviously works with subtracting 2 pi. Also, you're still going to end up landing at the same place. So basically what we are saying is, if I can take a given value of t and add 2 pi to it with my sine or cosine functions, I'm basically going to be completing a revolution and coming back to the same point. So we can actually use this idea of you can do as many revolutions as you like. So it's not just with one revolution, right? I can make 2 revolutions, 3 revolutions, and I still end up at the same place. So the idea is, if I take my given value of t and add a multiple of 2 pi to it, with both cosine and sine functions, I'm actually going to still land up at the original value where I started out as. So what that happens is, because of this repetitive nature, we can actually say it's a periodic function, because you're completing that revolution, you're still ending up at the same spot. And like I mentioned, this actually works with both by adding or subtracting a value from it. So we're just saying, as a definition, if you have a periodic function, you take a positive real number c in such a way that when I add it to my function, I still end up at the exact same function value. And this is true for any value of t in your domain. So the idea is, whichever is that smallest value of c that brings you back to the original number or original place is what we call as the period of your function. So for sine and cosine functions, that value of c, of course, is going to be 2 pi, because that's your complete revolution. Now for other trig functions, your tangent, cotangent, secant, cosecant, we'll talk about their periodicity later on, but as far as sine and cosine functions go, both of them have a period of 2 pi. Another thing you should remember is, from college algebra, we had talked about odd and even functions. So remember, with even functions, the idea is, if you put a negative value into your function, but it still gives you the same value as a positive t, that's what makes it an even function. For odd functions, if you put a negative value in your function, it's actually going to negate the entire function. So those odd and even values you can also see for these trigonometric functions. So cosine and secant are going to be your even functions. Sine, cosecant, tangent, cotangent are going to be the odd function. So the idea is, if I take, excuse me, a negative value for t, it's going to give me the same result if I had used a positive value for t. But of course, with the sine, cotangent, and their reversible functions, If you put a negative in, it's going to make your whole function negative. So I just want to look at these examples really quickly. We're talking in terms of the periodic nature of these functions, but then also talking in terms of odd and even. So if I'm looking at the value 13 pi over 6, you can actually rewrite it in this form of 2 pi plus pi over 6. Can you tell me how they came up with 13 pi over 6 as equal to 2 pi plus pi over 6? What did they do?
They did 12 pi over 6 plus the 1 6.
Very good. So yeah, they're breaking that 13 into 12 and 1. So 13 12 divided by 6 is where that 2 pi is coming from. And then you're left behind with pi over 6. So the idea is, and you know, we looked at this example last time of if you're given a value of t, how do you come up with the 6 functions for your trigonometric function? So you can use this idea of these functions being periodic to calculate these values also. So pi over 6 will be easy for us to calculate. It's going to come out to be 1/2. And since we know 13 pi over 6 is basically one more revolution added to pi over 6, you're going to have the same exact value for sine as you did at pi over 6. Using that same concept, we are looking at negative 7 pi over 2. So again, how did they come up with negative 4 pi plus pi over 2? How did they split this number apart? Because you've got a negative 4 pi and a positive pi halves.
Well, negative 8 pi over 2 is 4 pi. Negative 4 pi, and you add pi over half because it's negative.
To subtract that, yeah? So you're basically converting this into negative 8 plus 1, right? To get the negative 7. So negative 8 pi over 2 is where the negative 4 pi is coming from. And then we're adding a pi half so that it will go back to be negative 7 pi halves. So again, remember cosine is an even function. So if I put a negative value in, the answer is going to be same as though it was a positive 7 pi over 2. So now here we're talking about cosine at pi halves. Whatever is the value of cosine at pi halves is going to be the same thing at negative 7 pi over 2 because you're just making 2 revolutions in the negative direction, right? So you're going to end up at pi halves, which is of course at your 90-degree angle. You come back with cosine of 0. Sine is an odd function. So if you're going to take the value of sine of t as 4 over 5, that's the same result you are going to get if you make this a negative value of t, because remember, if you make a negative t in your sine function, it negates the entire sine value. So if this is positive t, you get 4/5. It's negative t, you will basically end up getting a negative 4 over 5 because of that odd function property. So using this idea of using the period of a function or a function being odd or even, I'll give you a couple minutes to work on this and let me see what you guys can come up with, and then we'll look at the answer. Okay, so for this first one, all right, so just by looking at that 9 pi over 2, you can break it up into 8 pi plus pi, right? And then 8 pi divided by 2, pi divided by 2, 8 divided by 2, of course, gives you 4 pi plus pi half. So the idea is you're basically right at the same point where pi halves would be with 2 more revolutions to get to that point, which would give us the 9 pi over 2. So this would be basically equivalent to that 4 pi plus pi over 2. Now, if you think about your unit circle, so pi over 2 is right here at 90 degrees, right? So think about this ordered pair. this is going to be, what's the x value here?
0.
0 and y value. So we know cosine is the first coordinate, sine is the second coordinate, so that means our cosine is going to be 0, exactly. So that's what the value of this guy comes out to be. So we're just basically falling back on those standard values that we will have in our unit circle, and then using the idea of this period to simplify our numbers, because if you're just coming to 2 revolutions, then there's no reason to do a big calculation on that. So using that same idea with sine of negative 7 pi over 3, so this was what, part A? So in that same way, how can we break down negative 7 pi over 3?
It's one rotation. So 2 pi.
So basically, you can break this down into negative 6 and negative 1 pi, right, over 3. And then in that same way, negative 6 pi over 3 minus 1 pi over 3 will end up giving us negative 2 pi, right? And just as I was walking around, and I talked to a couple of you, we don't want to make this into an odd number, because with even number revolutions, you are making a full circle. But if you make this into, instead of a negative 2 pi, a negative 3 pi, then you're only going half a revolution, so you don't get back to the same original point. So it's always going to be basically multiples of 2 pi, right? So that means we are looking at sine of negative 2 pi minus pi over 3. So again, just kind of looking at that negative pi over 3, what is it going to be? Do you know what angle is negative, or just pi over 3 for that matter? 60 degrees, right? So what you can actually do is, if you don't remember, we talked about this again last time, you can use that 30, 60, 90 degree triangle to help us out with what is the value of 60 degrees, right? And so it's going to be, I guess this guy is our 30, this one will be 60. Across from the hypotenuse is the longest side. Across from 30 degrees, the smallest angle is our smallest side. So what should this measurement? So what was that ratio for a 30, 60, 90 degree triangle?
Root 3, 2, and 1.
Okay, so which one should be across from the 30 degree?
Root 3. 2.
1, right? Because it's got to be the smallest measurement across from the smallest angle. So it's going to be 1. Now remember, root 3 is smaller than 2, right? So 2 is going to be your longest side, which goes across from the 90 degree angle, which automatically means you're looking at square root of 3 across from 60 degree angle. So we are talking about negative pi over 3, which is basically the same as sine of negative 60 degrees. So this guy being an odd function, if you're taking sine of negative pi over 3, that's going to be the same as negative sine of pi over 3, right? It just makes the whole function negative. So that means you're looking at
Root 3
root 3 over 2, right? Because you're looking at sine, which is opposite over hypotenuse, so that's going to be square root of 3 over 2. And it'll become negative because sine is an odd function because of that negative sign there. So everything that we talked about last time, you can basically use all of that to help you out based on what degree angle you're looking at, and then the definitions for your sine, cosine, tangent functions and their invertible functions themselves. So it's going to come out to be negative square root of 3 over 2. Okay, what about this last one here? Yeah, I think they actually updated the software, so now it's doing something completely different. What's going to happen here? They're asking us to find cosine of t, when the given value is cosine of negative t equals 0.3. Okay, so what would you do? You're not sure? Okay.
It's given to us in radians, right? So would you subtract 2 pi? Or would you just...
No, you don't even have to do any of that.
I would just, you gotta make it negative.
Don't even have to do that. So, nope, this doesn't let me scroll at all. I'm gonna have to figure that thing out. So maybe try 2 fingers out, then maybe that'll work. So it's actually falling back on the idea of these functions being odd or even. So cosine is an even function. So they're telling us cosine of negative t is 0.3, right? Which is also going to be the same value because it's an even function for cosine of t. So they're actually going to be the same value for both cosine of negative t.
So it's just constant.
Yeah, it stays the same. For part C.
Our cosine
Oh, I don't
and-
know, why did I say 0.03?
Are cosine and secant even functions because of the way that they graph out, or?
Yeah, pretty much, because you will see the symmetry. Because what was the symmetry for even functions? You had to choose between origin or y-axis.
Y-axis.
Y-axis, exactly. And then, of course, for odd functions, you have symmetry with respect to the origin. So you will actually see those on the graphs. Yeah, wonderful, very good. So, okay, so again, like I said, since these guys are even functions, the value of cosine of negative t is going to be the same as cosine of t. So that's all they were asking you on that part. Will you let me scroll or not? All right, so let's look at this last page here. We're talking about using calculators, and I think I've mentioned this a couple times now. You really got to be careful about what mode our calculators stay in, because if you don't keep that in mind, the calculator is not going to give you an error message or anything like that. So we just have to figure out what mode our calculator is in. And we had kind of looked at this last time. They're saying to evaluate your secant, cosecant, and cotangent functions, you can actually use that inverse key, but if you look on your calculators right above the sine, cosine, and tangent function, you will actually see they already give you the sine inverse, cosine inverse, tangent inverse, which are the reciprocal functions for your secant, cosecant, and cotangent functions here. So just some instruction on how you can type the values into your calculator, so you can kind of look through that. But let's see if we can come up with our own answers here. So remember, the first and foremost is to see what your degrees are given in. If you don't see the word degree or the little symbol for degree, you have to assume it's a radian measurement. So of course, sine of 2 pi over 3, that has to be in radian mode. You have cotangent of 1.5, but 1.5 does not have a degree next to it. So again, that means it's in radian mode. So let's see what answers you can come up with for sine of 5 pi over 7. And they didn't really tell us about the rounding, so let's do at least 5 decimal places. So what do you get for sine of 5 pi over 7? Rounded to 5 decimal places. Bless you.
Thank you.
Yeah, so basically all you have to remember is that your calculator is in radian mode and rounded to 5 decimal places, 0.7. What are you going to do for part B, which is cosecant of 2.0? So which key do you use for cosecant?
Inverse or sine.
Say that one more time, sorry.
Inverse or sine.
Yeah, because remember what we talked about with the reciprocal functions. Yeah, very good. Okay, let me go ahead and write this since it didn't really take on that other one. And what did you come up with?
This is not fair.
Math error. Okay, I'm not sure why.
Yeah, I got error. I got 1.09. I don't know.
Okay, hold on a second.
I got domain error.
You got domain error as well?
You put it in. Or did I do it wrong? Last.
Yeah, yours close. The parentheses have to do with the and then go to it. And then raise it to another. So cut it into 3 right after the 2.
Basically, you're typing in the 2.
Oh.
Okay, what if we changed our strategy a little bit, if that's not working? Cosecant, how else can I write it down?
Yeah, I. You sign and then
Yeah.
the power.
Say that one more time.
You sign and then you just do the power of the.
Power of -1, okay? Isn't that what you really did when you did that T? Remember, this is the reciprocal function for sine. So what if you type this in? What do you get?
Yes. 1.099.
Yeah.
Isn't that what you had,
Yeah.
Jose?
So if you take, you could just find the sine of 2.0 and then enter it like the previous answer. That's the inverse, and it'll be the same thing.
Yeah, because cosecant is basically the reciprocal of the sine function. So if the cosecant sine inverse is not working out, go ahead and do 1 over sine or 1 over cosine. And again, round it to 5 decimal places. What do we get?
0, 0, 0, 0, 0.
No. I got
Wait.
1.0997.
1, 2, 3, 4, 5. You should not
Oh, wait,
have to
no,
do
no,
all that
75.
rounding.
My bad.
Because you got a 0 after that, right?
Yeah.
So you don't really have to round up anything.
Maybe it's
I have a question on that.
Sure.
I know I probably won't use this one on the test anyways. But is that not a valid
Yeah, because what is happening here is you're actually taking the inverse of the tangent function, but here you're actually making this as 1 over 1.5 when you put the inverse on the number. You're actually keeping it as tangent, but you're changing it from 1.5 to 1 over 1.5 when you put that
Oh.
inverse on the 1.5.
Okay.
How come when in the like the second and then inverse it doesn't give you?
So what I am thinking then that means these calculators are actually thinking of them as true inverse functions and not the reciprocal function. So it's very much possible that our calculators are not recognizing that sine inverse or haven't been programmed sine inverse as the inverse function, but more in the traditional sense of inverse.
I mean, if you do it like exactly like that, the parentheses outside.
Yeah, if you put a negative one exponent, it works.
So
Yeah.
for that one, if you want to use that inverse key, then this is what you're going to have to type in. For the inverse key, you're actually going to have to do, come on, buddy. Sine of, well, basically 2. And you would need to put this whole thing in parentheses. You would actually start with parentheses, then do your x to the -1, and that should work. Because I didn't try it that way. So let's see, parentheses, sine of 2, inverse. So yeah, that's working. So you either use the x to the -1 key, or this is what I actually normally do, is just do 1 over sine. The 2.0. Okay, I actually wanted to see if you guys are interested in earning some extra points. Problem number 50 on page 138 of your textbook. And remember, you can access the ebook online. So if you want to try and doing problem number 50 on page 138 for extra points. Okay, so that will be the end for 1.2.